Okay, so what we're going to talk about today is, although acids and bases are kind of aggressive compounds, if you will allow me saying that, on their own, but what's really cool about when you mix them together, they neutralize each other. The reason being is when you mix them, the H plus that gets donated from the acid and the OH minus or the hydroxide from the base forms water, H2O. And so what happens after that, once the H and OH leave, what's left over is the anion of the acid and the cation or the metal from the base. Well, if an anion and a cation come together, they form what's called a salt. We know these as our ionic compounds. And so I'm going to go through a few examples of showing kind of what happens from neutralization. So we have the H from the acid and the hydroxide from the base. Those come together, form water. Sometimes you'll see it written as HOH, just as like a, I don't know why they write it like this, but you guys should know water is a 2 H's and an O. Then our salt that forms would be NaCl. Chloride being the anion from the acid, sodium, metal, or cation from the base. And so those come together, form our salt. Let's do another one. So next one is with sulfuric acid and potassium hydroxide. And so now what we have is we'll make a mole of water for every hydrogen we have. So we have 2 hydrogens here. So we end up getting 2 hydroxides because of the coefficient. We needed that to balance. So we'll get 2 moles of water. What's left over then is K2SO4. This is our salt, potassium sulfate. And lastly, if we have nitric acid and calcium hydroxide, they will come together, also forming 2 moles of water. We had to balance with a 2 in front of the acid because of the 2 hydroxides that come from the base. So pretty much saying for every 1 mole of calcium hydroxide, we need 2 moles because there has to be an H for every group of OH, or there has to be an OH for every H that the acid donates. So we use coefficients to balance these things out. It has to deal with how many moles of each we need to neutralize. And that's really important when we do our calculations in this next part here. Then our salt is calcium nitrate. Any questions about these here? Okay. And so what we're going to talk about next here is called titration. So this is what your lab will be on Tuesday. So you guys are going to be titrating to figure out the concentration of a base or an acid. And so this is what it's used for. Just kind of gave it away there, but it's for finding concentrations. So you literally could walk up and see it just says HCl on a bottle, hydrochloric acid. Have no idea what the concentration is, but you could do a titration with a known concentration of base and figure it out. And so we're going to go through those calculations. And so what's really helpful here are using our indicators. So we talked about our indicators are different molecules that turn different colors depending on what pH we're at. And so we're going to use them to determine what's called the endpoint. So these couple things are going to sound similar, but endpoint is when the indicator changes color. It has reached its buffering capacity. Endpoint. Then we have this insight into what's called our equivalence point. So the endpoint could be a slightly acidic or basic, depending on if it's above or below 7, but it kind of tells us when we're at the equivalence point. The equivalence point is when the titrated solution has a pH of 7 or neutral. This means that the concentration of the hydronium ion, which is our H3O plus, so this is just the H plus being added to a water molecule, is equal to that of the hydroxide, or OH minus. Those concentrations are equal, we're neutralized, but the thing is with the indicator, for example, we'll use phenolphthalein. That kind of has an endpoint around pH of 8. So it's not an exactly neutral or equivalence point. If we really want to make sure that we are pH 7, you guys would use a probe. So titrations are more for close enough. But if you wanted to actually make sure it's neutral, use a pH meter. All right, so we are going to talk about solving these problems. Pretty much figuring out how many moles of acid we need to neutralize so many moles of base. We're going to have to figure out concentrations and volume. So we're going to just do a few variations here. And so what you need to know is that 1 mole of an H plus neutralizes 1 mole of OH minus. So this is where we have to consider using the molar ratio from the balanced reaction. We also have to remember that molarity is equal to moles over liters. So a lot of times you want to solve for moles. If you solve for moles, it ends up just being your concentration in molarity times your volume in liters. My pencil's not cooperating. One moment here. So let's just say moles is equal to M times L. What this allows us to do is we can then find out how many moles of acid or base and set up a relationship that way. So if we have, or if we want to find our moles of acid, that's just going to be equal to the concentration in molarity of acid times the liters of the acid or the volume. You can do the same exact thing for the base, where we'd have moles of our base is equal to the concentration of base times liters of the base. And so ideally, we want to get these things equal to each other because we know it is neutralized. And so this first example here is just strictly working with moles. And it asks how many moles of LiOH are needed to neutralize 2 moles of H2SO4. So the key here is if we think about the reaction that's happening, we have lithium hydroxide being added to sulfuric acid, which will make water and lithium sulfate. Is this reaction balanced? No. You should be shaking your head no. So what we need to do to balance it is put a 2 here and a 2 here. One thing, so you don't have to write out the equation every single time. If you have 2 hydrogens from your acid, you're going to make 2 moles of water, just so you guys know. Or if you need, or if you have 2 hydroxides, for example, you're going to need 2 moles of your acid. So really this ratio, because there's an invisible one here, is 1 to 2. It's going to take a little bit more base to neutralize because it only has 1 hydroxide per mole. So where this comes into play, if you have 2 moles of H2SO4 that we're trying to neutralize, if you were to use the molar ratio, for every 1 mole of H2SO4, you need 2 moles of lithium hydroxide. So where I'm pulling these numbers from is that molar ratio. Now, I'm fine if you guys can do this in your head. That's great. I'm just showing you where this is coming from. So how many moles of LiOH will we need then? 4. Any questions about this? So we're just making sure that every hydrogen from an acid has an OH pair, or vice versa, making sure every OH has an H pair to make water. All right, let's do the next example then. So if it takes 15 milliliters of a 0.4 molar solution solution of sodium hydroxide to neutralize 5 mils of hydrochloric acid, what was the initial concentration of HCl? So this is very similar to what's kind of going to go on in lab. So we're going to determine the concentration. So approaching this problem, if you're comparing HCl and NaOH, do either of them have an extra H or OH? They just have one each, right? This base has one hydroxide, this acid has one hydrogen. That's a 1-to-1 ratio. So we don't even have to worry about writing out. We know that for every 1 mole of NaOH, it's only going to take 1 mole of HCl. Now we need to figure out is how many moles of our base did we even use to neutralize? So how can we use a volume and a concentration to figure out how many moles we have? Multiply, right? We rearrange, molarity is equal to moles over liters. If we rearrange for moles, we just end up getting molarity times liters equals moles. So that's what we're going to do for sodium hydroxide. We're going to say, all right, if we have a 0.40 molar solution and 0.015 liters, making sure that I'm converting mils to liters, that gives us 0.006 moles of NaOH. Now we just said that acid to base is 1-to-1. So if we have 0.006 moles of NaOH that it took to neutralize, how many moles of acid do we have? 0.006. So this value now becomes our moles of acid because of our, or I guess in our case, HCl. We determined how much base was used to neutralize. We know that at the neutralization point, they have to be equal. And because of the molar ratio, we know it's 1-to-1, it stays the same. How can we get a concentration from our moles of HCl and our volume of HCl? Moles over liters, that is molarity. So now when we're figuring out the molarity of HCl, we just take our 0.006 moles of hydrochloric acid over, making sure to convert our 5 mils to liters, 0.005 liters of HCl. It'll get that the molarity was 1.2. Dun, dun, dun. So again, where I pulled those last values from are here. Any questions? Okay. Next one here. How many milliliters of a 2 molar sulfuric acid solution are required to neutralize 30 mils of 1 molar sodium hydroxide? So for this one, paying attention to how many H's we have. We have 2 here, and we have 1 OH. So which one are we gonna need more of to neutralize? The OHs, right? So pretty much what we need to know is for every 1 mole of H2SO4, we'll need 2 moles of NaOH. So that'll be important here in a second. Again, we're going to take that same process. We're going to figure out how many moles of base we are talking about and convert that to moles of acid. And so starting off with our concentration and volume, making sure to turn mils to liters. If we have a 1.0 molar, remember, same thing as moles per liter, we're going to multiply that by our 0.030 liters of NaOH. That tells us we have 0.030 moles of NaOH to neutralize. Well, according to our molar ratio, since it's not 1-to-1, we have to do a quick conversion. So if we have 0.030 moles of NaOH, we're going to have to convert that using what we determined here. So for every 2 moles, it'll only take 1 mole of sulfuric acid. That means we only have 0.015 moles of H2SO4. So now this question is slightly different. It wants to know how many liters or milliliters it will take to neutralize. So again, thinking about how molarity is equal to moles over liters, do we have a concentration for sulfuric acid? Yup, we do. It's right here. So we'll plug that in for M. 2.0 molar. Then we're going to plug in our moles here, the moles that we just determined. 0.015 moles H2SO4. We are then solving for liters on the bottom of this fraction. So all we would be doing is swapping liters with the 2 molars. So this would move up here. This would take its place. So if you take 0.015 moles divided by 2 molar, we get 0.0625 liters or 6.25 mils. That's how much sulfuric acid it would take. Any questions about this one? Oh, it's 7.5. Wow, I grabbed the wrong answer. Come on, guys, be on your toes. Why is this not working? Well, apparently it's not letting me erase. So. I grabbed the answer for the next problem on accident. Alrighty. Next one here. So this one's saying how many mils will it take of the base to neutralize the acid. So in our case now, looking at our ratio, we have 2 hydroxides for every 1 hydrogen. That's kind of hard to see now that that's in the way. So we have 1 hydrogen, 2 hydroxides here. So for every 2, for every 1 mole of calcium hydroxide, we're going to need 2 moles of nitric acid to neutralize it, because nitric acid only has 1 hydrogen to contribute. And again, you can find these always by writing the balanced chemical reaction. So when in doubt, write out the full reaction. All right, first step here. Figure out the number of moles of the volume and concentration pair. So in doing so, we multiply the concentration by the volume in liters. So we have 0.50 molar nitric acid times 0.025 liters. That means we have 0.0125 moles of HNO3. We're going to have to do another conversion here because it's not 1-to-1. So I am going to take the 0.0125 moles, and we are going to use the molar conversion of for every 2 moles HNO3, 1 mole calcium hydroxide, which means we have 0.00625 moles. Oh my gosh, I'm gonna throw his pencil through this roof. So frustrating. I think I need a new one. It's been acting out lately, guys. I don't know. I think I write a little too hard and it's getting mad at me. So for here, again, we're looking for how many milliliters. So we're going to use the similar setup as we did in this problem here, where if we're solving for liters, that's going to be equal to the moles over molarity. So in our case, it's going to be 0.00625 moles over 0.10 molar. So this is in reference to calcium hydroxide. That gives us our 0.0625 liters or 62.5 mils. Any questions about this one here? Okay, doke. This last one, super short, quick. What if it just wants to know how many moles are required? So this one's even simpler. You get to stop pretty easy. So what is the ratio between hydrochloric acid and sodium hydroxide? This is a 1-to-1 ratio. So all you need to know is how many moles of base you have. That's how many moles of acid you'll need. So if it's 1-to-1, you figure out how many moles of base. It's 2.0 molar times 0.1 liters. You get 0.20 moles of base, which if it's 1-to-1 equals your moles of acid. So that's how many moles of HCl you need. Any questions? Okay, I know you have questions.